Okay, ladies and gentlemen, we're going to take a brief look at solving trigonometric equations involving quadratics. One thing that I want you to keep in mind is this: anytime that we're talking about a quadratic, we mean a biggest exponent of what number? 2. Hopefully you thought about the number 2. And as we take a look right here, our biggest exponent for sine is the number 2. How do we solve one of these equations? Well, we can solve one of these equations very similarly to the way we solved quadratic equations back in algebra. You probably remember, if we had an algebraic quadratic equation, the first thing that we tried to do was we tried to go ahead and see if we could set that quadratic expression equal to 0. Second thing we tried to do is tried to go ahead and factor. Keep in mind, we always take out our greatest common factor with that first. And then the third thing that we try to do is to use our zero product property, or some books call it the zero product principle, to set each factor equal to 0 and solve. So set each factor equal to 0 and solve. Now, of course, the question pops up, what if the expression doesn't factor? Because sometimes factoring is not possible. Well, if it doesn't factor, then we need to use our quadratic formula. In our problems, that won't be a problem. Let's go ahead and take a look at this first example. As we take a look right here, we've got 2 sine squared x minus sine x equals 0. It is set equal to 0 already because we have equals 0. Let's go ahead and factor this. How do we factor this? Well, we take out our GCF first. When you look at these two terms right here, there's obviously a sign as a factor in each one of these terms. In fact, I'm going to insert a 1 right here because I can do that. I can multiply sine by the 1. And then I'm going to think of this term here as really consisting of a 2 times a pair of sine factors. So sine x times sine x. This term right here, I'm going to ignore the minus. I'm going to think of this as consisting of a 1 and also a factor of sine. Now, when we take out the greatest common factor, we want to see what's in common with these two parts right here. And both of them clearly have a sine. And so what we'll do is we'll take that sine factor from both of these, and we'll take that out in front. So here we're going to be left with sine x, and then everything else goes in the parentheses. So we have a 2 sine x in front, bring down the minus, and then here we have a 1. Now, there's no more factoring we can do, so now we're going to set each factor equal to 0. This very first factor right here, if we want to, we could put parentheses around it. It still means multiply. We don't need to do that. Let's go ahead and set this equal to 0. Sine x equals 0. Let's take the entire second factor, set that equal to 0. That gives us 2 sine x minus 1 equals 0. And let's go ahead and isolate the sign here. So it looks like this. To get this sign alone, we'll add 1. And we'll divide by 2, and that's going to give us sine x equals 1/2. Now, the final step in the problem is to figure out where on the unit circle sine x equals 0 and where it equals 1/2. Keep in mind, our domain here is from 0 to 2 pi. So that's just once around our unit circle. Where does sine x equal 0? Let's take a look on a unit circle down here. Sine x is equal to 0 where the second number is 0, and the second number is 0 here at 0 radians. It's also 0 here at pi radians. So 0 and pi would be our answers for this part. Let's write that in, 0 and pi. Where does sine equal 1/2? Well, that would be where our second number is 1/2 on the unit circle, and our second number is 1/2 right up here, and it's 1/2 right up here. So that's going to be at pi over 6 and 5 pi over 6. So let's list those out here. Pi over 6 and 5 pi over 6. And that would be what we end up getting there, 4 answers. Typically, these quadratic problems will have 4 answers, 3 answers, 2 answers, 1 answer, or 0 answers. Let's go ahead. And what I want to do is give you a problem to try on your own. So I want you to try this next one. Practice it, and then we'll go through that. So pause the video and give this a try, please. Okay, let's go ahead and work this problem through carefully, doing exactly what we did above, and see what we end up getting here. First thing right here is we see a common factor of cosine, so I'm going to pull a cosine out in front. And that leaves us inside the parentheses with cosine plus 1. Next step. Let's go ahead and set each factor equal to 0. Here we're going to write cosine x equals 0. And here we write cosine x plus 1 equals 0. Sorry about that. Next, let's go ahead and solve for the cosine. If we add -1 to both sides, we're going to end up getting cosine is equal to -1. Keep in mind on our unit circle, cosine is going to be which number? First or second in the parentheses? It'll be the first number. So let's take a look on our unit circle. Where's the first number equal to 0? Well, when we look on our unit circle, first number is going to be equal to 0 here at pi over 2. Also equal to 0 here at 3 pi over 2. So we're going to get pi over 2 and 3 pi over 2. Where does our first number equal -1 on the unit circle? Well, at this point in time, you should be pretty comfortable with your unit circle. Hopefully you can do this in your head. Your first number is equal to -1 on your unit circle at pi. So for this problem, 3 answers. All right, let's go ahead and take a look now at a problem that's going to be a little bit different. What I want to do is have a skip the tangent example, because we've done a lot of tangent examples. I want to have us move right into example number 5, where we've got something a little bit unusual. Cosine squared x plus 2 cosine x plus 1 equals 0. How do we do this problem? Exactly like we did the others. As we take a look, we have a trinomial. It is quadratic. The leading coefficient equals 1. And we know anytime that happens, we need to find numbers that add to 2 and multiply to 1. Well, you can do that in your head. What multiplies to 1 and adds to 2? It's going to be 1 and 1. So let's go ahead and factor this. Now to get cosine squared, it's going to need to be cosine times cosine. Think about it. When you do FOIL, cosine times cosine gives cosine squared. Now the positive ones are going to go right in the parentheses. Next step. Let's go ahead and now set this equal to 0. If we do that, we're going to get cosine x plus 1 equals 0. If we set this equal to 0, we're going to get the same equation, so we don't need to write that twice. Next, if we solve for cosine, we're going to get cosine x is equal to -1. Now, on your unit circle, where do we have the cosine or the first number equal to -1? That's going to be right at pi. So the answer here is going to end up being pi. Now, every once in a while, a student will say, Mr. R, I don't know if my answer is correct. Well, one way to see if it's correct is to take that answer, plug it back into the original problem. We didn't get a chance to do that in class, but let's do that here and prove that this is, in fact, an answer to this equation. I'm going to take the pi, I'm going to plug it in here, and we're going to end up getting cosine of pi. And that whole thing will be squared. I'll put it like this. Plus 2 times, plug in the pi there, cosine pi. Plus 1 equals 0. Now, let's see what happens. What's cosine of pi? Think about your unit circle. That'll be -1, right? Next, let's simplify this by using PEMDAS, or order of operations, exponents first. This gives us a 1. When we multiply right here, we got a -2. Combining those together, 0 equals 0. The answer checks. The next time that we get together, we're going to take a look and see what happens when our domain is not from 0 to 2 pi, but when our domain is from -infinity to infinity. And that'll open up a whole different world of possibilities here. All right, ladies and gentlemen, we'll pause it right there. Hopefully that helped just a little bit, and we are all done. Bye-bye.